Alright, in this video we're going to go over permutations and combinations. Alright, so here's your vocab. To start with, we have the fundamental counting principle, which is a method of using multiplication to count. And then a permutation is an arrangement of items in a particular order. A combination is an arrangement of items in which order doesn't matter. An n factorial is simply n followed by an exclamation point. And what that means is, say you have 3 factorial, it's going to be 3 times 2 times 1, which is 6. So for factorial, all you do is multiply all the successive numbers together up until whatever you have for n. So if you had 6 factorial, it'd be 6 times 5 times 4 times 3 times 2 times 1. Okay? So that's what n factorial is. Alright, permutations and combinations. Now, these are the formulas for both of them, but I'm not actually going to make you do these by hand. I'm going to let you do them on calculators because they're just so much easier and faster that way. But I want you to know what the formula looks like, so if you ever see it again, especially on the EOC, you know what it is. So the number of permutations of n items of a set arranged r items at a time is NPR, this is your symbol for permutations, NPR, equals n factorial, so the number of items you have, divided by the number of items you have, minus the number of items in each set at each time, and then it's the factorial of that. So like if you have 10 items arranged in 4 groups, or arranged in groups of 4, it'd be 10 factorial divided by 10 minus 4 factorial, so 10 factorial divided by 6 factorial, which is 5040. And then combinations, remember, in combinations, order doesn't matter. All right, the formula is almost the same, except you have r factorial in front of it right here. Okay. So remember, permutations, order does matter. Combinations, order does not matter. And really, the toughest thing about permutations and combinations is trying to figure out, is the order going to matter or is the order not going to matter? That's really the hardest thing to figure out with these. Okay. So, finding the number of permutations of n items. Now, for this example, I'm going to demonstrate the fundamental counting principle. It says, in how many ways can you file 12 folders, one after another, in a drawer? Well, if you have 12 folders, you can pick any one of those 12 folders. So you have 12 possible combinations for the first file in the drawer. Well, then you're going to multiply that, because remember, we're using multiplication to count. You can multiply that now. If you put the one folder in, now to choose which folder you want to put in second, you now have 11 possibilities, right? Because you've placed one folder in, so now you have 11 left, so now you can pick one of those 11 for the next one. After you place the second one, you have 10 folders left that could possibly be in the third one. All right, so you see how this is going? This is basically saying you have 12 factorial ways to put 12 file folders into a drawer, one right after the other. All right. So the answer to this is you would just simply do 12 factorial, which is a really, really big number. So you have a lot of ways. Okay. So that's your fundamental counting principle. Okay. If you have a certain number of objects and you just want to find out how many different ways you can arrange them using all the objects, it's just your number of objects factorial. Okay? It's just your number of objects factorial. All right, now let's look at actually using permutations. It says 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third if no ties are allowed? Okay, if no ties are allowed. Well, we could use the fundamental counting principle to start with. Okay, we know that any of the 10 runners can come in first. after somebody comes in first, there's only 9 runners left, so any of those 9 could come in second. After first and second come in, there's only 8 runners left, so any 8 of those could come in second. Now, since we're only worried about first, second, and third, we're not worried about how many different combinations can all 10 runners come in. We're going to stop the fundamental counting principle at 10 times 9 times 8, okay, which comes out to be 720. Now, to do permutations with this, let me bring over my emulator, okay. So now, with permutations, what you're going to do is if you have an Inspire, you can do a lowercase n, a capital P, and a lowercase r, and then open a parenthesis. Okay, we have 10 runners, and we want to know how many different ways that the top 3 can finish. So we're going to do NPR, and then 10, 3, and that'll give us our 720 different ways. Okay. Now, different calculators will do permutations differently. Tomorrow in class, I'm going to pass out the calculator that you're going to have to use on the EOC, and we're going to go over how to do these on that calculator. Because, like I said, every calculator does it a different way. So I want you to know how to do it on the calculator that you're actually going to use on the EOC. Okay. So for permutations, that's really it. I mean, permutations aren't that hard. You just, how many items do you have? And with permutations, order matters. So how many items do you have? And how many groups, or how many items in each group do you want? So like for this one, we have 10 items, and we want it in how many groups of 3? How many different groups of 3 can we have? All right. Now, combinations. Remember, combinations order does not matter. So let's take that same problem. It says, suppose in problem 3 that the first 3 runners advance to the championship race. In that case, the order in which the first 3 runners cross the finish line does not matter because all 3 of them are going. So it doesn't matter. Okay? A selection in which order does not matter is a combination. Okay? So with a combination, order doesn't matter. So what we would do in this case, instead of using permutations, we'd use combinations. So in CR, okay, we got 10 runners. You know, how many ways can we just get the top 3? Now, say Johnny came in first, Sally came in second, and Susie came in third. Okay, for permutations it matters because who wins gold, who wins silver, and who wins bronze. But if all 3 of them just go, it doesn't matter if Johnny comes in first or if Johnny comes in third, he's still gonna go. You following me? So in that case, there's only 120 different ways that you can get a group of 3 out of 10 people using combinations. Okay? Because like I said, in order doesn't matter, so it doesn't matter if it's Susie, Johnny, Sally, Sally, Susie, Johnny. It doesn't matter because the top 3 are going to advance. Okay. But as far as assigning gold, silver, and bronze medals, the order does matter. And since the order does matter, the group Johnny, Susie, and Sally is different than the group of Sally, Susie, and Johnny because they get different color medals. Okay? So that's pretty much it for combinations and permutations. Remember, with one of them, with permutations, order matters. With combinations, order does not matter. All right? So feel free to watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.